and welcome to the people on campus as well. So tonight we're going to be looking at spreadsheet modeling. I'll need another minute just to get myself set up, so it shouldn't take very long at all, and then I'll be with you. Okay. 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 Well, welcome to the second week of ITLS 5050. This week, as I said, we're going to be looking at spreadsheet modeling. You can see it now. This week, we're going to be looking at spreadsheet modeling, and we're going to do a few exercises as well as do some build a spreadsheet model. So for this evening, you'll need to be in Excel, and you'll need to be in on Canvas as well, so that you can access the materials that you'll need, the template and so on. So that's what we're going to need tonight, Excel, and you need access to Canvas so you can access the templates. We don't need those yet, but we'll need them in a little bit. So, as I said, tonight we're going to be discussing spreadsheet modeling. Spreadsheet modeling is one of those techniques which is very widely used. And many of us do spreadsheet modeling all the time without even knowing that it's called spreadsheet modeling. What this means is spreadsheet modeling is more of a series of tools that we can use rather than a specific technique. Okay? It's like a hammer. You can use a hammer for all sorts of different things around the house. So yeah, that's what spreadsheet modeling is. Okay. We're going to look at some of the more powerful features of Excel that if you're not so familiar with Excel, you may not have come across before. Even if you are familiar with Excel, you may pick up a few things which you didn't know. I've certainly learned things over the years while teaching this particular section, finding new things in Excel all the time. And Excel is always being tweaked by Microsoft to add in some new features from time to time. One thing that I find with Excel is there's lots of different ways to do the same thing, which means if you find a way which works well for you and you get a good answer, then yeah, go for it. Don't worry about it. So that's what we're going to be looking at tonight. We'll start by having a look at decision analysis again. We did cover it in a bit of detail last week, but I'll talk a bit more about it tonight. Then I'll introduce the concept of spreadsheet modeling. and the important steps of working out what it is that you want to do before you actually build your model. Why that's so important is because you don't want to build the model in a way which it won't give you the answers that you're looking for, or it won't allow you to improve the model in the future. So that's why we're going to look at the steps before we actually build a model. Then we'll have a look at a simple model, the Great Threads model, and talk about how this feeds into the rest of what we're going to be looking at over the year. So let's get started by having a look at decision making. Now, I said last week that management decisions are complicated because there's risk and uncertainty, multiple objectives, complex structures, and multiple stakeholders. We spoke about that last night when we were looking at demand forecasting, if you were studying with me last night, where we saw that there's multiple stakeholders who have an input into demand forecasts and who use demand forecasts. Each of those players will have multiple objectives, and the organization itself has multiple objectives. There's also risk and uncertainty there. We just don't know what demand is going to be next week because the people who want to purchase our product haven't decided they want to purchase our product yet. Complex structures, well, yes, demand can have quite complex structures because it's the sum of all the individual decisions made by your individual customers. So it can have a complex structure, although the demand forecast we tend to be a little bit simpler than that. Although wait until the demand forecast week and then you may change your mind and think that demand forecasting is actually very complicated, depending on how you find the models. So let's think a bit more about some of those decisions which have multiple objectives. In your personal life, I hope you've all managed to have holidays from time to time. When you choose a holiday, there's a lot of different factors that you'll be looking at. When I think about a holiday, I think about somewhere with beautiful scenery, some enjoyable activities. I like a comfortable hotel. It doesn't have to be luxury hotel, just comfortable enough. I also like to feel reasonably safe and secure. I don't want to think that I'm going to be at risk of being mugged or something like that, but I don't mind a little bit of risk, and that comes with the territory. I also obviously would rather not spend that much money on it. If I can get a good holiday at a lower price, then that would be good for me. Adding in some new extra steps probably would be a place which has a low risk of getting sick now. That's probably moved up in people's holiday objectives. I know it's certainly moved up in my decision making around holidays. Those are my factors when I go for a holiday. But everybody is different with the holidays that they choose. Some people are going to want more of an adventure holiday. So they'll want somewhere which has a lot of exciting adventures. Other people will like nightlife more than me. So they're going to look for places with amazing bars and nightclubs. Other people will have very different objectives. Right? So we're all different in our objectives there. But most people have more than one objective when they're choosing a holiday. It's the same when a company chooses a supplier. Some of the things that they'll look for include, are the goods fit for purpose? Do they do what they need them to do? They'd also like the best after-sales service, the fastest delivery time, the best reputation for reliability, and the lowest prices. Now, it should go without saying that very unlikely to find one company which has the best after-sales service, fastest delivery times, best reputation for reliability, and the lowest prices. So they have to make some trade-offs. And of course, different parts of the organization will have different perspectives on that. The IT department might be looking for a company who can supply goods which are compatible with the existing software that the company uses, if that's relevant, so that the IT department doesn't have to invest scarce resources in accommodating the new supplier systems or the supplier's products. The warehouse will probably want to know that the company can supply goods to whatever timetable the warehouse operates on, so that the goods come at a convenient time for the warehouse. And they come relatively frequently, or whatever the frequency is that the warehouse likes to receive goods. Lots of different competing objectives. That can be a little bit tricky for some of the models that we look at. So in the next 2 weeks, we're going to be looking at linear programming models. Linear programming models have one single objective. You can only optimize on one thing at a time with a linear programming model. That makes it a little bit tricky if you've got multiple objectives in real life. So we need to think about how to deal with that. Can someone suggest in the chat box some of the different options you might have for dealing with that multiple objectives if you can only use one objective in your model? Any suggestions in the chat box? And while the people online are thinking about that, how about the people in the class think about if there's ways to build in multiple objectives into a model? So people online think about how you can cope with one objective. People in the classroom think about how you can build in multiple objectives. I'll give people a few minutes to think about that. Type your answers in the chat box. Thanks. So people in the class, did you come up with any suggestions as to how you might be able to deal with multiple objectives? Include them in your analysis. List them according to their importance. So the first suggestion was list them out according to their importance. Sitong, you suggested control variable as one way of dealing with a single objective. Could you explain that a little bit more for us?
Hello, I mean, because we have several objectives, we can just make one of them stable and or just sorry, I can't explain clearly. I think.
Well, are you saying we could pick one of the objectives and just ignore the other ones?
Yes.
Yeah, that's certainly possible, yes. So pick one objective and only focus on optimizing on that objective. That's certainly a very practical solution. So, yep. So Amita was suggesting Pareto charts. That sounds like it's similar to what we heard here in the classroom about listing things out according to their importance. So you may come up with some sort of a weight. One way of generating weights for the different objectives is, yes, using linear regression. So you come up with some sort of a weighted objective. So you give 20% importance to this factor, 10% importance to that factor. Yeah. And there's a special online only component to this course at the very end on Canvas on multi-criteria decision making. We don't just have time to include it within one of the classes, but it's up there online about multi-criteria decision making, how you can build that in using weights for each particular objective. Any other suggestions at this stage? Yeah, so Hugh's just trading off the multiple objectives. Yep, using a scoring system to see which is the most important. Yep, so working out, that's another way of working out which is the most important. All of those are reasonable approaches. One of the benefits of spreadsheet modeling is it can at least accommodate multiple objectives. You may not be able to optimize on all of them at once, but you can at least see how your plan functions against multiple objectives. So that's one of the benefits of spreadsheet modeling, is you can at least track how it goes against those objectives. One approach which is quite common would be to work out what the optimal course of action is to satisfy each one of those objectives. That gives you a range of the better options. And then you just pick which one of those options seems overall best to you. So if the idea is, or the objective might be maximizing market share and maximizing profit, you find this course of action which will let you maximize profit, and then you find the course of action which will let you maximize market share. If they give you the same result, then great. Yep. You've worked out that you can satisfy both objectives at the same time. If they give you something slightly different, well, then you can work out a compromise somewhere between the two. As I said, one of the benefits of spreadsheet modeling is that you can see how your plan functions against multiple objectives all at the one time. I spoke last week about how we simplify problems often to cope with limited information. Coming up with a weighted measure, ignoring some of the objectives, all of those are ways to cope with complexity. We just need to remember when we simplify things that we get at what's important, but we may ignore some otherwise important information as well. So the question then becomes, why model? Well, models are a great way to overcome our intuitive limitations. That is, the limitations of the human mind. We find it hard to deal with complexity. We find it hard to deal with multiple objectives all at once. By putting your thoughts down into a model, well, you can overcome some of those human limitations. It's usually not a replacement for what we call the holistic approach. The holistic approach to decision making is to just use your brain. Use your common sense. Try to think about all the potential issues. Well, if this happens, then what happens, in order to come up with a good decision. So that's based on your own knowledge, your own experience, your own beliefs, attitudes. All of those are important factors in helping you make a decision. And there's increasing amounts of study taking place into that sort of level of decision making. How is it that some CEOs are always lucky and others are less successful? Is it just that they are lucky? Is it just that they had a good run? Or is it that they're using their experience and applying that to make good decisions? And so that's what's being looked at. This unit is more about quantitative models, though. So that's what we're going to be talking about. Some of the pros of building a model: we can uncover relationships we were not aware of before. It's a logical and systematic approach, and we can explain to others how we arrived at our recommendations. But we do need to keep in mind that all models are a simplification of reality. So now let's talk a little bit about the modeling process. Now, we often face a situation, an issue, or a problem that we need to solve in order to make a decision. We've spoken about a lot of them already in the classes we've had so far. But some more examples. What demand should we expect next month? Which investment option should we choose? Will buying a new forklift truck improve our warehouse operations? Should we change suppliers? All of those decisions are very common ones that are faced. So, what's happening there? The process is like this. We have a situation that we're facing. It might be we need to increase our profits. It might be we need to know what to produce next month. That's the situation we face. We need to make a decision in the real world. What are we going to do about that? We've spoken about how making that decision can be difficult. So here's how a model works. Before we do that, just mention about how judgment helps us to make good decisions. That is what I was talking about before, that you bring in your education, your experience, your common sense. All of those are parts of your judgment to help you make a good decision. But I also pointed out that there's often limits to that when the situation becomes so complex, or there's too many objectives just to rely on your judgment. That's when a model helps. So we step away from the real world for a minute and we build a model. The technical term for this is we're abstracting from reality. We're leaving the real world and moving into the symbolic world. Now, you don't need to memorize these terms. Just giving you these terms to explain what's happening. So we're abstracting from the real world to the symbolic world. So we're abstracting from the real world to the symbolic world. We're building a model. And how we do that? Well, our judgment plays a role again. We then use our model to generate some results. Again, judgment plays a role in working out how that happens. Then we interpret the results to make our decisions. And again, judgment comes in there. Now that's quite a bit of extra work, isn't it? Gone from just making a decision using our judgment to using our judgment to make a model, to make some results, using our judgment again to interpret the results in order to make the decision. So why do we do that? Well, we do that because up in the symbolic world, we can roll time forwards. So we can model what our supply chain is going to look like 6 months from now. We don't have to build a time machine to come back from 6 months and see what it's going to happen then? No, we can roll the supply chain forward. If we're wanting to make a decision, do we build a new warehouse or do we expand our existing warehouse? You can only do one or the other because there's not money to do both, and you may not even be sure that you should do either. Well, you build a model and you see what would happen under both scenarios. So you can explore more options in the symbolic world in a model than in real life. By simplifying reality, as I said, you may be able to uncover relationships you didn't know existed before. You may be able to find information that you couldn't have found otherwise. So that's why we build this model. But remember, our judgment is still central to the modeling process. Your judgment doesn't disappear just because you've built a model. You still need judgment in each of these steps. That said, more and more of the world is being run automatically using artificial intelligence and all of those technologies, big data models, where humans don't have a whole lot of input into what's happening. The model does it all for us. Those are outside the scope of this unit, but you will look at them in other units that you study, these techniques. So, any questions at this stage about modeling?
Who should be involved in building up the model?
So who should be involved in building up the models? Good question. The answer, unfortunately, is it depends. So in my experience, most logistics analysts or supply chain analysts, they'll step into a role. There'll be the existing models that are already there for the organization, and part of the job might just be updating it for the next quarter or the next time period. Okay? So managing existing models. However, there will be occasions where you have to come up with a new model yourself. So for instance, you're thinking about a new investment, you'll do some of that analysis in an Excel spreadsheet or in an ERP package or what have you. So you may need to build new models. I've also worked as a consultant where I've been hired in by organizations to build some of those models for them. So the answer is it really depends. If it's a simple model, it might be that you have that already built and you're just rolling it forward. May also be the organization has specifications for how their models are going to be built. If we do a demand model, it has to be built according to this. If we build if we're going to look to build a new warehouse, well, we need to use this particular model for that decision-making process. Certainly, anytime you deal with government, there's usually very standard approaches. So some of the work I've done with government, there's a manual which might be 100 pages long, specifying exactly how the model should look and what it should do. And then it's just a matter of putting that in practice. Yeah. But that's always a good question. Thank you. Any other questions at this stage? Okay, so let's now look at spreadsheet modeling. What is a spreadsheet model? Well, the name says it all, basically. It's a model that's built in a spreadsheet. But what does that mean in practice? Well, it means entering inputs and decision variables into a spreadsheet and then relating them appropriately using formulas in order to generate outputs. So you enter the inputs into Excel, you specify the functions and the relationships in the model, then Excel does the calculations and it gives you the outputs. And it's one of the quantitative methods to model and solve a decision-making problem. Most of what we're going to be looking at in the rest of this semester are just applications of spreadsheet modeling, more advanced applications or different applications of spreadsheet modeling. We're going to look at a few examples tonight. Bear in mind that the models we look at tonight are just examples to show you A, how the modeling technique works, and B, what some of the common formulas are. They're not ones that you may go through your whole career without having to build that specific model. These are just examples to help you understand how the technique works and how the tools work. So hopefully that makes sense. So all spreadsheet models will involve inputs. That's data that we're given. Where do they come from? Well, it might be that it's information that's already known. What were our sales last month? It might be information that you find. So what is the interest rate that the bank is charging? What's the US dollar exchange rate today? Information that you put in there. It might be an assumption that you make. So you may think, well, let's assume that in 6 months' time, interest rates are going to be 4%, or the US dollar exchange rate is going to be 80 cents. So that could be a number you assume and you put in. It's up to you to work out what inputs you need and where to get the numbers from. There may also be decision variables. These could be controllable. So numbers you could put in to see what happens. And we'll have a look at some of those as we go through tonight. You'll get to understand the differences, what these terms mean better when we actually look at some in practice. There are some parameters which you'd need to enter. That could be as simple as there's 100 centimeters to 1 meter. It's just something which is a given, which is uncontrollable. It could be the cost of postage. Depends on the situation. And then the outputs, well, those are the ultimate values of interest. What it is that we're wanting to do. Typically, that will be your objective. So whatever your objective is, that's typically your output, but not always. It does depend on the circumstances. I've tried to be very general with the terminology I'm using here without being too vague. I'm trying to be as general as possible so that you can see how it gets applied in different circumstances. So for instance, regression modeling is about working out what the parameters are. Linear programming is about calculating what the best value for the decision variable should be. It's in how much we're going to produce. In order to maximize our output. So different spreadsheet models deal with these inputs, decision variables, parameters, and outputs in different ways. Simulation modeling says, don't just assume a value for the input. Let's test a whole lot of different random values for the inputs to see what happens. And we'll look at that at the end of the semester. Does that make sense so far? So, now, what comes next is obvious, but it's worth saying anyway. No manager is going to take seriously a model if they don't understand it, or it's cumbersome to use and maintain. I've seen lots of models which were so complicated that no one could work out how to update the values, or they just never bothered updating the values in there, and it ended up being a waste of money. So make sure when you set your model up that you make it user-friendly. I'll be showing you some tips and tricks on how to do that as we go through the semester. how to make your model user-friendly and easy to understand and interpret. They're just suggestions. You're welcome to use whatever works for you. Another thing that is important to understand is that no model is totally realistic. So a simple model may be just as realistic or just as useful as a more complicated model. That's very hard for analysts to understand because I know from my experience, you always want the best model. And so that means making a more complicated model or searching for just the right parameters to use. And you can end up spending years and years and years coming up with a very slightly better model. So one of the things to think about is your budget before you build a model. That could be time or it could be money. In most cases, it's going to be time. You know, how much time can you spend on this? One thing which works really well in my experience is to start out with the simplest possible model you can and then add in extra components. So for instance, start out with a model for the total demand for all your products over the next month, and then break that down into predictions for each product line, or daily predictions, or predictions for each store. You know, adding complexity as you go along, making sure that the simple model works before you start looking for the more complex one. It's also a lot easier to troubleshoot a simple model than a complicated model. And if you then add in that complexity, if you make a mistake, well, you can always unwind it. I'm speaking there from years of experience in that. I don't want to sound jaded. It's just that's what works well. Yeah, so that's what I was saying there. Build a simple model that works, then add extra details or refinements. So at least you know that the simple model works if you do it that way. And make sure you give people a reason to use it. Making it easy, user-friendly, nice to look at, that's very helpful. I had a colleague and a friend of mine who used to get paid to build good spreadsheet models. That was one of the services he offered. He would set it up really nicely. That was quite a lucrative role. First good habit is make sure your model is readable so that someone who comes along after you can understand what you've done. That person may even be you coming back 6 months from now. So here's an example. This is the one we're going to be looking at tonight. You'll notice that the inputs are separate from the outputs and both are clearly labeled. There's use of colors, bold text, formatting. It's all quite straightforward. And you should, even if you don't know anything about the problem, you should be able to understand what it's talking about and what it's doing in general, just by looking at it. So that's an example of what I think is a good design. As I've said before, these are my preferences. Your preferences can be completely different. So long as it's user-friendly, that's all that matters. So other good habits: clear and logical layouts, clear headings, using formats. Some of the things which people find helpful are separate sheets for different parts of a model, naming ranges, putting in cell notes or text boxes, comments, those sorts of things. Any other questions at this stage? Okay, so let's take a 5-minute break now. Get up, have a stretch break, and then when we come back, we'll look at going from the problem to the model. Okay? So have a 5-minute stretch break, and we'll come back. Yeah, then. Hello again. So before the break, we were talking about some of the elements of a spreadsheet model. Now we'll go and have a think about how we go from the problem to the model. The first thing to do is to study and understand the problem. So here's an example. Simon is an apple pie wholesaler who wants to make a profit. In the short term, there's not much he can do. He can't change his suppliers. He can't change his recipe. He can't change the size of the pies. He can't change the quality of the pies or anything like that. So in the short term, there's not much he can change. There's good and bad about that. I mean, it's bad if he wants to make a quick change because he can't. On the other hand, it stops him from chopping and changing what he's doing all the time. And it also allows us, though, as modelers, to simplify the problem a lot because there's not much he can do. Yeah. Did I mean, sorry? He can't change. Yep, that's certainly one thing. Yes. Yeah. So first question, what is his objective? So somebody writes in the chat box what his objective is. Yeah. Yeah, thank you. To make profit. Okay. Now, we heard one example from the class of what he could do to meet his objective, to better meet his objective, and that was to change his price. Someone from the class give me another example. Yep. Yep, change the quantity that he sells. So he could try to change the quantity he sells. He could try to change the price that he sells them. So that would help him to make more profit. Yep, in the short term, yep, we'll assume he can't do that. Yep.
Talk to the supplier to negotiate a contract terms so that there can be a whole client for the entire years.
Yep, so yep, that's a good suggestion, is to try and come up with a new contract with his existing suppliers. I'm saying that's something which he can't do in the immediate short term, that he'll need a little bit of time to do that in. But yes, that's another thing that he could do if he's got enough time. Change the process. Well, he doesn't have time today to learn a new recipe. So we'll put that one to one side as well. Another good suggestion, though, to come up with a new recipe. Tom suggesting setting a minimum quantity for purchase. Yeah, let's assume that it takes him a little bit of time to do that as well. And marketing, another good suggestion what he could do, but let's say that that's a medium-term thing he could do, not a short-term thing. You'll see what we're doing here is, first of all, understanding what his objective is, and then brainstorming what he can do to meet that objective. Now, I'm taking the role of Simon here, telling you whether something can or can't be done, which is very common. Otherwise, it might be just that you list everything down and then you think about it. Most organizations, when they're thinking strategically, well, that's when they think about all sorts of things that they haven't thought about. So suggestions about minimum order quantities, marketing, coming up with a new arrangement with the suppliers. All of those might be strategic discussions which take place, over coffee at a retreat or something like that, where they come up with what they can be doing over the longer term. Here, changing the price, changing the quantity, those are more short-term operational issues. So now we've thought about our objective and what we might be able to do about it, we specify our model, just putting down some words as to what we want it to achieve. So profit, that's his key objective. And he decides that out of all the options that he's heard, what his most critical decision will be is the wholesale pie price. So how much does he charge his customers when he sells them pies? So the price he charges, that's the main thing that he can influence to make a higher profit. So that will be his decision variable. So after hearing all of your good suggestions, and there's some more coming through the chat box, thank you. He's decided that what he cares about most, or what the most critical decision will be, is what wholesale price to charge. So now he's going to set out the specification for his model. He doesn't need to worry yet about how the model will work. He just lists what he wants from the model. You can think about it almost like a checklist. I want my model to do this, 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 and this. And so once it's built, you can say, oh yes, it does what it specified. He just lists what he wants from the model and what information he thinks will be needed to put into the model to make it work. So if profit is the performance measure, the objective, the key factor, what contributes to profit? Any suggestions? What constitutes to profit? Unmute your mic or put it in the chat box. Yep, sales volume. Price of ingredients, thank you. Any suggestions? What contributes to his profit? Yep, the wholesale cost. So the cost of the ingredients, yep. Anything else? The quantity of ingredients. Some other suggestions, cost of distribution. All of those could be relevant factors. Here's what I came up with. So, Simon wants to make a profit. I highlight that yellow because that's the overall objective. Why yellow? It's just the convention we use. I actually have no idea who invented that convention. We've just been using it for years now, so we'll keep using it. He wants a model which will help him to work out his profit. What needs to go into that model? Well, the pie price. That's the key decision-making variable. The key one that he's interested in, what price to charge. Then he knows he's got some fixed costs. He has to hire to pay the rent on the factory or the investment costs on the factory, whether it's run or not. There's some electricity costs, no matter whether it runs or not. Those are what we call fixed costs. Then there's the recipe that's used. So what quantity of ingredients are needed? How much do those ingredients cost Simon? And how much does it cost to process the ingredients? In this case, is how much does it cost to bake a pie? Does that make sense? Yeah. Yep. So these are what Simon thinks his model is going to need. Why is this useful? Well, Simon's had a chance to think about, do I have access to this information? Do I need to simplify some things here? Yeah. Is it even possible to get that access to that data? The next advantage is once Simon's built the model, he can go back to this list and see, did we actually include all of those things? Yep, tick them off.
What's the difference between the pie price and the addition of cost ingredients, processing costs, and fixed costs?
Good question. So, yeah, just let me explain the terminology I'm using. Simon purchases ingredients So Simon pays for those ingredients. And then Simon follows the recipe, which says, 200 grams of butter, 15 apples, whatever it might be. Yeah. He follows the recipe used as he bakes the pies. The cost to bake a pie, that's the processing cost, because it's, so it's the baking cost. And then the fixed costs are things which Simon has to pay no matter whether he does anything. So it might be a security guard, warehouse staff, whatever. Even if there's no baking going on, he still has to pay things. The cost of the vehicles, even if the vehicle's just sitting there. That's the fixed costs. Then once he's baked the pie, he sells the pie at whatever price he says. So that logic makes sense to everybody? Yeah.
Technically, the higher the price is equivalent with the addition of all the cost and the ingredients and processing.
If Simon wants to make a profit, then the pie price has to be equal to the cost of the ingredients plus the processing costs, plus some contribution to the fixed costs, plus whatever his margin is. Yep. But I mean, in the short term, he may have to sell the pies at a loss, and ideally, he's wanting to sell the pies at a very high cost or very high price, so he makes the most possible profit. Make sense? Okay. So, yeah, that's the model. So what's next? What I find helpful is to visualize the model. Sometimes that might be just a simple flow chart. If you're talking about a spreadsheet model, it's often referred to as an influence diagram. An influence diagram just shows what all the inputs are and all of the outputs are and how they're linked. It doesn't include any of the model's mathematical logic. So it's just what are the inputs, what are the outputs, what are the linkages there. So you start with the performance measure variable, you break it down into its key contributors, and break that down and so on, until you've broken the problem down enough to solve it. Let's have a look at what that would look like. So we start with profit. Why profit? Because profit is the key objective of Simon. And then we say, well, what determines our profit? If you're an accountant, what's profit equal to?
Price minus costs.
Yes, very good. Yeah, revenue minus costs. Thank you. Yeah. So what contributes to profit? Revenue and your total costs. And you'll see there's an arrow going from revenue to profit and from total cost to profit. So the arrows go from the input towards the output. Why? Well, if we know what Simon's revenue is and we know what his total costs are, then we've worked out what his profit is. Does Simon know what his revenue is at this moment? Does Simon know what his revenue is at the moment? No, he doesn't know that yet. So he needs to break this down. See how that works? So he doesn't know what his revenue is yet. So he needs to break that down. And you keep doing this step by step until you've broken it all down to only information you know. So what influences revenue? Well, it's the price times the quantity. Price times quantity gives you revenue. So if he knows the price he charges and he knows the quantity he makes, he can work out his revenue. Now, the wholesale price charge, that's one of the things he wants to calculate. So that's why it's green, because it's something he wants to calculate. Red just means it's something he can work out. Or it's something he can guess, something he's going to assume. So it's a known value. So then we come to total cost. We spoke about Simon's costs being a function of the fixed costs and the ingredients cost and the processing cost or the baking cost. So how much it costs to bake, how much the ingredients cost, how much the fixed costs are. See how we've broken that down a little bit further? So now we break down processing cost. His processing cost is going to be a function of the number of pies made and how much it costs to process each pie. So if it costs 10 cents to bake a pie and he bakes 1,000 pies, then it will cost him $100. The ingredients cost, well, that depends on the quantity of ingredients and how much each of those ingredients cost. So quantity of ingredients and the unit cost of the ingredients. What determines the quantity of ingredients? Well, that's the pie recipe and the number of pies made. Okay. Sorry, just making a note for myself. So yes, the quantity of ingredients depends on the number of pies made, the pie recipe, and the unit cost of ingredients. Now, that's all information he knows or information he wants to get from the model. Each step of the way, as you've broken it down, you need to ask yourself, is this something that I know? Is it something I can guess? Or do I need to keep breaking it down further? He wants to work out what price to charge, but he already knows what his cost structures are, the unit cost to bake, the unit cost of ingredients, the fixed costs, he knows what those are. He knows what his pie recipe is. He knows how many pies he wants to bake. So all of those are known factors, known information. That's why I highlighted them in that sort of pink color. What that means is that there's nothing left to break down any further. And you can go back and check against his model specification. Every input has an arrow leading out from it. Every output has an arrow leading into it. This is a very simple model, so each of these are just a single number. In practice, of course, you may want to set up a submodel for each of the elements. So for instance, the number of pies made, you could make that a function of the price that you charge. You might think if I put the price up, then I won't sell as many. Therefore, I should factor that in. That could be a simple demand function. And in other units I teach, not in this program, but in other units I teach, we look at the demand function and how to incorporate that into a model like this. So that's what we can add to a model. That makes sense? So here, these components are just numbers. In practice, they may be submodels involved. Once you've got your influence diagram, then you need to think a little bit more about the logic. How does revenue influence profit? Well, it's revenue plus total costs equals profit. So you think then about the mathematical linkages, and you then build your spreadsheet. So you then specify the relationship between the inputs and the outputs, and you put them into your spreadsheet. So profit is revenue minus total cost. Revenue is pi price times the number demanded. Total cost equals the sum of those three separate costs. Then you actually build the model in Excel. Notice here how opening up Excel is the 5th step in the process. So if you're working on a spreadsheet model and you see the problem, don't just immediately open up Excel and start typing. Think about these steps beforehand. Okay? Once you've built your model, you're not finished. You need to think about error checking. Some of the ways that I do that are to check each formula and check each number. Just make sure it's all working. So if you've got 20 cells in your spreadsheet with 20 numbers, check each of those 20 numbers, make sure they're correct. Check each of the formulas to make sure they're correct. It's time consuming, but it does work. And you'll see that when you go through some of the other models we build, you make a mistake, well, you just have to go back and check it out. Another thing which works really well is to change the numbers in some of the cells and see if the model performs as you'd expect it to. So if you raise the price, does that lead to more revenue and more profits? If you increase the quantity he bakes, does that lead to an increase in the amount of ingredients used, the total costs, and the revenue? See how the logic works there? You should be able to see that those things work. We'll look at some other tips and tricks as we go through. One of the ones which is quite useful, and unfortunately a student emailed me today to suggest that this might not be available in Max at the moment. If it's not available in Max at the moment, Microsoft has said that they're putting it in, and yeah, so it should be there eventually, but it's not 100% essential. Even if you can't use it, it's just a useful thing. I'll show you that when we built a model, the precedence and dependence. And you can see if it's available in Max. Then you interpret the results and you do some sensitivity analysis, depending on whatever you're interested in. So Simon could use this model to see, well, what happens if the unit costs go down? More likely at the moment, the unit cost might go up. So there's a lot of flooding taking place in Australia. If you're overseas, you may have seen it on the news. That's likely to lead to higher costs for things like fruit and vegetables. And so, yeah, that could have an impact on his model. Simon might say, well, I saw in the paper today that apples are going to go up by $1 a kilo. What does that mean for my profit? He can then do that sensitivity analysis by making the change in his model, seeing what happens. Then some of the other good suggestions that we heard for longer term changes, they can be built in as well. So you made the good suggestion, maybe they can change the supplier contract before. Changing the supplier contract might change the cost of the ingredients. So you could see what that might look like. We had a suggestion about changing the recipe. I think over here, I think that came from. And so you could see that in the model. Yeah. We thought about the marketing. There's no marketing component built in here, but you could build that into your model by looking at the relationship between the prices charged and the number made. So boosting your marketing budget would add to your costs, probably under the fixed costs, but it might allow you to raise the price or raise the number you sell. So you could build that into this model, or you could add in some extra components for that. There were quite a few other long-term suggestions that were also great, which you can build into your model as part of your sensitivity analysis. Yeah. So that's the basics of building a spreadsheet model. I used a very simple example there. Aisha asks a question, how do we actually do that sensitivity analysis? Well, the easiest way to do that with a spreadsheet model is just to change the numbers in the spreadsheet and see what happens. So that's the easiest way of doing sensitivity analysis. Change the numbers, see what happens. Next week, when we look at linear programming, we'll see that Excel has some sensitivity analysis tools built into their spreadsheets, which will give you some useful outputs as well. So you don't actually have to make all the changes to the model. Okay. So here's an example of a spreadsheet model question. Now, this might sound outdated to people who are used to e-commerce, but back in the old days, this is how online shopping worked before there was online shopping. And in fact, there still is a lot of mail order catalogs out there, mostly tailored to an older segment of the market. So it's not completely outdated model. Yeah. But let's have a look at this scenario. So the Great Threads Company sells jumpers by mail order. They sell them, as I said, mostly to an older market. A jumper is like a t-shirt, half between a t-shirt and a jacket. It's if you don't have jumpers where you're from. Yeah. So the Great Threads Company sells jumpers by mail order. They plan to print a catalog and then send out that catalog to their mailing list. Then their customers will go through the catalog like a magazine, and they'll say, oh, yep, I like that one, that one, that one. If they want to, they'll post back their order, and then the Great Threads Company will ship out the clothes to them. So that's the plan. The Great Threads Company wants your help in modeling what might happen. Some background information. It costs $20,000 to set up the catalog ready to print. Then it costs 10 cents per catalog that they print. So even if they don't print any, it'll cost $20,000. But then if they print another 10,000, then it would cost an extra $1,000. They then have to post out the catalogs to customers, and that costs them 15 cents per catalog that they send out. So that's what happens when they send out the catalog. If the customers like what they see, well, they'll place an order. And the way they do that is using a reply paid envelope. What that is just an envelope. The customer puts their order in the envelope. So, just a piece of paper with what they want to purchase in the envelope. And they don't need to put a stamp on it. The customer doesn't put a stamp on it. They just put it into a post box. When it comes back to the Great Threads company, the Great Threads company pays for the postage. So the reply paid envelope lets the customers post back their order for free. So customers don't pay for the postage. The company pays the postage. They pay 20 cents per order received. That's an important point. They pay 20 cents for every order they receive. So if a customer doesn't purchase anything, there's no reply paid cost to the firm. They only pay for an order. Now, all of that is on the cost side. So if I was to sit down with Great Threads and say to them, tell me what your costs are. And they would say, well, most of our costs come from printing the catalog and posting it out. We then have to pay for the orders, the postage on the orders when they get sent back to us. The other cost is, of course, the cost of fulfilling the order. The cost of the item, the cost of handling it, posting it out, all of those things are the last cost. I would say, okay, that's great. Let's think about that in a little bit more detail. First, think about the revenue side of things. What does your revenue side look like? Now, that's a problem because they just don't know what the customers are going to want to buy. They don't know how many customers are going to place an order, and they don't know what each of those customers are going who place an order, what they'll actually want. So the number of orders, the amount of revenue, quantity purchased, all of that is still uncertain. So we say, okay, well, give us your best guess. Or usually, how do you think about this? And the company comes back and says, well, remember, this is a simplification, but we think on average, an order will be about $40. So if a customer purchases something, they'll usually order around about $40. Some customers less, some customers more, but on average, $40 per order placed. Okay, so that's great. That's an indication about the potential revenue. The next simplification is how much will it cost to fulfill that order? Now that will depend, won't it? If a customer orders a lot of items, then it might be cheaper to process that order and send it out to the customer per item, cheaper per item. Some items will be more expensive than others. So the markup might be different depending on the item. So again, uncertainty. However, the company tells us, well, we expect that the fulfillment cost will be around about 80% of the order value. If it's more than 80%, then we think we're in a bit of trouble. If it's less than 80%, well, then we get more money, but we may not sell as much. So our target is fulfillment will cost about 80% of the order. Again, a simplification, but one which is going to be useful for our model. The last thing you need to know is, well, how many catalogs are you planning to send out? And they say, well, we plan to send out 100,000. So does that make sense now? Yep. Any questions about that? They expect to send out 100,000 catalogs, an average size of a customer order about $40, and around 80% of the order value will be the cost of fulfillment, plus then the postage out, postage back, and the cost of printing catalog in the first place. Okay. So I had a question, can I explain the 80% again? Yeah, perfectly fine. So if a customer orders one jumper from us, let's say that jumper is $20. So the customer pays us $20 for that jumper. Now that jumper is not free for us. We have to get the jumper from somewhere and we have to get it to the customer. So there's the cost of manufacturing the jumper, or probably more likely purchasing it from a wholesaler. There's the cost of fulfilling the order, as in putting the order in a box, sealing it all up, posting it out. All of those are the costs associated. We have a good idea about how much it costs, but it will all depend on what item the customer orders, how many items they order at the same time, and how many other orders they've got to deal with on the day. Lots of different factors. So instead, we come up with an average, though, of around about 80% of what the customer spends, we have to pay on fulfillment costs. And the other 20%, we get to keep. So for that $20 worth of stock, the $20 they give us to buy product, we'll have to spend about $16 to get the product to the customer.
Excuse me, sir.
Yeah.
I want to know that 80% of the order's value covers the postage cost or not?
It covers the cost of posting the goods out to the customer. So that 80% covers the cost of the jumper and getting the jumper to the customer. The 20% that's left over, that has to be spent on the reply paid envelopes, the cost of printing, producing the catalogs, and sending them out to the potential customers. So that last 20% has to cover all those other costs as well as make us a profit. That make sense?
Yeah, sure.
Excellent. Okay, so that's the situation. The company then wants to answer these questions. Well, they want to know about their profit. Clearly, they're a profit maximizing firm. They want to know about profit. The next thing that they want to know about is the unknowns. What they don't know, they know how many catalogs they'll send out. They don't know what the customers are going to purchase, but they've estimated it to be about $40. They don't know what the fulfillment cost will be, but they've estimated it to be about 80% of revenue. All that leaves is, well, how many people are going to place an order? That's the last bit of information they need. Yeah. Say again, sorry?
The shipping cost of the products ordered from the warehouse.
Yep. They know, well, they don't know it precisely because the question was, do they know how much it's going to cost to post the items out to the customers? They know how much the catalog will cost to post to the customers. They don't know how much the product will cost to ship to the customers because it depends on exactly what they order. So if they order one, like if you think about it, well, Amazon has a range of fixed size boxes, as does Australia Post. Amazon has obviously lots of different size boxes, but there's a fixed sizes. And so if you can fit one item into that box, if they order one item, you'll put that one item in the box and send it off. If they order two items, might need to be in two separate boxes, or one bigger box. So it'll depend, the cost of posting out to the customer will depend on exactly what the order is that the customer places. Does that make sense? They could calculate all the possibilities, but it will depend on precisely what's ordered. So the main unknown is just how many people are going to purchase something from the catalog. So they ask some questions. How does a change in the response rate affect profit? What response rate does a company need to break even? If they think they'll get a response rate of 3%, should they go ahead with the mail out? Now they can develop a spreadsheet model to address all of these questions. The first thing I want you to do is build an influence diagram. So, what I'm going to do is put you into Teams. And what I want you to do is spend about 10 minutes building the influence diagram for this particular problem. So here's what the influence diagram looks like for the previous problem we did. What I want you to think about is building the influence diagram for this particular problem. So think about the influence diagram for the Great Threads example. You'll need the information that you get out of here. Does that make sense? So build an influence diagram similar to the one you've got here. Does that make sense, everybody online?
Yeah, it makes sense.
Excellent. Okay. Great. So I'll put you into breakout rooms and work on an influence diagram. And take about 10 minutes and then we'll come back. Okay. Welcome back, everybody. We'll just give the students another couple of seconds to return. Okay, so, well, welcome back, everybody. I went to all the different groups and it all looked like you're on the right track, which was good to see. That said, it can be a little bit tricky to build influence diagrams the first couple of times you look at them. And certainly if the model is complicated, well, then building an influence diagram becomes a very complicated challenge as well. What I wanted you to get out of that was an understanding of what an influence diagram is and how you go about building it. I strongly suggest you get some practice at building influence diagrams. The practice questions up on Canvas include quite a few spreadsheet model questions where you can practice building some more influence diagrams. Okay. You may be asked in the computer exam to build an influence diagram. Remember, you need to have a box for every input and every output. The arrows need to be pointing from the inputs towards the outputs And yeah, then you got an influence diagram. Now here's my influence diagram for this particular problem. It's possible that you came up with a different looking influence diagram. Maybe you had some different inputs and different outputs in there. You almost certainly would have arranged it differently. This took me quite a little while to work out how to get the influence diagram onto a page without having any lines going over the top of other lines. I can do that because this is a simple influence diagram. No matter how complicated it actually looks, it is still simple enough that you don't need to have lines going over the top of each other. In practice, obviously, sometimes you need to, or at least I do, because I can't work out how to build an influence diagram all the time, which doesn't have lines going over the top of each other. So let's take that in, bear that in mind as I show you my influence diagram. Your influence diagram could be slightly different, but still compatible with mine. And if it is, that's no problem, so long as it does the right job. That's all that matters. Here's how my influence diagram works. I've got profit up here at the top. That's the thing they're most interested in. Profit is a function of cost and revenue. So profit breaks down into revenue and cost. What influences revenue? Well, it's the average order size and the number of orders. That $40 and the number of orders. The average order size, that's given information. The number of orders, though, well, that depends on two things. The response rate that they get, so the percentage of people who send in an order, and the number of catalogs they post out, the quantity of catalogs they print and post. So the number of catalogs printed determines the number of orders, along with the response rate. So that's all the information we need for the revenue side. We don't know what the response rate is, but at least we can put a box in there for it. We do know the number they're going to print and the average order size they're expecting, so that's known information. Then we break down the profit. I said total cost here. And I break down the total cost into printing costs, mail out costs, mail back cost, and the order fulfillment cost. Now, you might have a different way of breaking that down. That's just purely an accounting thing, depending on how it is that you want to aggregate those numbers. Does that make sense? If you aggregate them slightly differently, not a problem, so long as you have the same figures in the end. So let's look at the printing cost. That's a function of the unit print cost, the fixed cost to print, and the quantity printed. Remember, there was the fixed cost, and then the variable cost per catalog printed, and again, the quantity printed. If you know the quantity you print and how much it costs to print, so how much it costs to post out each catalog, then that gives you the total mail out costs. Remember, the important point about the mail back cost is the mail back cost depends not on the number they send out, but the number of orders received. So that's important to remember. The mail back costs depends on the number of orders placed by customers, not the number of catalogs they send out. That's that line there. So that's the mail back costs. Then the order fulfillment, well, it depends on how many orders they receive. The percentage of each order that's spent on fulfillment on average at 80%, and the average order size. So if you know all of that information, then you can work out your profit. It's not particularly relevant in this case, but when you look at a diagram like this, you can start to see where the central items are. So the quantity printed, that connects to a lot of places. The number of orders, that connects to a lot of things. The average order size, that connects to a lot of things. That can be useful information sometimes. For instance, you might need to spend more time thinking about that, or you may want to get more accurate number, or what have you, depends on the situation. So does that make sense there? Excellent. Any questions at this point? Yeah.
What's the difference between unit print cost and fixed cost?
Yep, what's the difference between the unit print cost and the fixed cost to print? So the fixed cost to print is that, what was it? It was, sorry, $20,000, wasn't it? Yep, so the fixed cost is $20,000. So that's how much it costs to create the catalog and to start the printing presses. And then the unit print cost, that's the extra 10 cents per catalog printed. Yep. So the printing firm will charge us $20,000 plus 10 cents per catalog printed. Okay. So as I said, sometimes you might have a slightly different format. That's perfectly fine, so long as your overall model still works. Okay. How do you know if your model will still work? Well, the more you practice these things, the more insights you'll get. You can always have a look at my answer compared to the other one. You can always come to the consultation or send me an email. I'm happy to help you there. Okay. So that's the influence diagram. Now we've got the influence diagram, we can start building our model. How does that work? Well, if you've got a good influence diagram, it's really, really simple. All you need to do is make sure that there's one spot in your Excel spreadsheet for each of those boxes. So you need to have somewhere in your Excel spreadsheet for profit. You need to have somewhere in your Excel spreadsheet for total cost, et cetera, et cetera. So all of those need to be a cell somewhere in your spreadsheet. Easy. The next thing that you need is that any output has to be linked with a formula to its inputs. So the profit function here, the value in the profit cell has to be a function of the revenue and the total cost. So the boxes in the influence diagram tell you what cells you need to use in your spreadsheet. The arrows tell you how the formula is going to work. You need to add a little bit more information in. So the formula for profit is revenue minus total cost. You can't see that on the diagram, but you know that you have to have a profit cell, a revenue cell, a total cost cell, and profit has to be a function of revenue and total cost. See how that works? The idea is the more time you spend on specifying this, the less time you'll need to spend thinking when you build your spreadsheet model as well. So more time spent thinking here, less time spent thinking building your spreadsheet model. And in fact, it becomes just a simple exercise. So let's have a look at that. As I said, if I was doing it from scratch, I would make sure I've got somewhere in my spreadsheet for each of these boxes and formulas to link it. For this tonight, I'm just going to save us a little bit of time. I've created a template. So you can see the template up on Canvas. This for the week 2. If you go to Welcome to Week 2, you'll see the Great Threads template that's there. The influence diagram is also there as well. So download the template and open it up in Excel. Okay. So what have I done? I've just created this template here simply so we can save a little bit of time tonight. So rather than having you spend the rest of the evening typing in all the bits of this spreadsheet, I've just created the spreadsheet template for you. And your job will be to now put in the numbers in the inputs and create the formulas for the outputs. Okay. So your job is to take this influence diagram that we just looked at, take the influence diagram we just looked at and build that into this inputs and outputs. I've done a lot of the work for you and I've listed out the inputs and listed out the outputs. So all you need to do is put the numbers in for the inputs and put the formulas in for the outputs. Okay. So spend 5 minutes, 10 minutes maybe, doing that. If you want, I'll put you into the breakout rooms again so you can work on that together. Do you all understand what the task is? Great. Okay, I'll open up the breakout rooms again. I'll give you 10 minutes to put the numbers in for the inputs and calculate the formulas for the outputs. Okay, so Chinyu, is Chinyu in the room? Oh. No. So did you have a team? Sorry, I wasn't recording just for the last couple of minutes there since we came back. Sorry about that. You type equals E17 here. You highlight this box here. And then we click data. What if analysis and data table. So you click data, what if analysis and data table. In a Mac, you may well be able to see data, what if analysis, data table. Otherwise, in a Mac, it would be the tools menu up the top, the tools menu, and then it should say something like what if analysis, or it might have goal SQL data table listed there. So, yeah, data, what if, analysis, data table. That brings this up. Data table, like so. What we do next is this. We say our response rate is in the column. The response rate is in the column. So we click on the column input cell. The response rate is listed in the column, so we click column input cell. Then we come over here and we click on the input. So here we're telling Excel that you can find the inputs over here in our spreadsheet model. So the input value that we're interested in, the response rate, we tell Excel that you can find it over here. Then we click OK. And this pops up. This tells us that if the response rate is 0, they can expect to make $45,000 loss. If the response rate is 10%, they can expect to make $33,000 profit. See how that works? There's also a two-way data table that you can create if you want to test two inputs at the same time. I'll record a video later this week where I'll show you how to do that two-way data table, which will let you test what happens if two inputs change at once. So the response rate and the postage cost, for instance. Now we can see the impact on profit of a change in the response rate. Every 1% increase in the response rate earns us an extra $7,800 profit. Okay. The last thing I want to show you tonight is the answer to the other question. The other question is, where do we break even? Break even is when your profit is equal to 0. Now, someone's already put that answer in the chat box. Well done. But let's see if we can narrow it down. What is the range of the response rate at which we break even? Based on this data table here, when do we break even?
Between 5% and 6%.
Yeah, well done. Between 5% and 6% we break even. So we know somewhere in there we break even. I could sit here and type values in until I get to a break even value. So somewhere between 5.7 and 5.8 breaks even, and then just refine it that way, guess and test. On the other hand, we could get Excel to do that for us. And that's what's called goal seek. So I can click the goal seek button again under data what if analysis goal seek, or tools what if analysis goal seek if you've got some kinds of maps. Click on goal seek and this pops up. This is straightforward. It says set profit equal to 0 by changing the response rate. It's easier if you read it up from bottom to top. We want Excel to tell us what response rate we need in order to get a $0 profit. What response rate do we need to get a $0 profit? I click OK. And did you see that Excel took a couple of steps? You may not have noticed it online. It may flash by too quickly. But Excel takes a couple of steps to work it out. And it works out that response rate of 5.76, 923076923077% gives us a profit of $0. We're break even. Would I tell my manager, if she asks me, when do we break even? Will I tell her we break even at 5.76923076923077 response rate? No. But my manager would look at me like I was crazy, and then she would tell me, you're crazy. What we need to do is to round that off to a reasonable number of decimal places. Okay, so whenever you give me a number, make sure you round it off to a reasonable number of decimal places. When I did science as a high school student, they always said 3 decimal places was the rule of thumb. That's fine for science, but in business, 3 decimal places would still be too many. 5.769, no one's really going to want that level of detail. 5.8%, that's fine. So usually use the rule for business and logistics and supply chain management is use 1 less decimal place than you think is reasonable. Just like packing for a holiday, always pack less than you think you're going to need. So yeah, 5.8% seems reasonable to me. On an assignment, if you gave me 5.77%, or you gave me 6%, or even 5.770, you're not going to lose any marks. if you give me all of the decimal places without doing any rounding, then yeah, you might lose a mark or two. So make sure you do round things to a reasonable number of decimal places. In Excel, you can get it to round the display on the home tab here under number by changing that, or by right-clicking the mouse and formatting cells. Again, in the video, I'll show you a few little tips and tricks for that as well. All right. So that answers their questions. A response rate of 3% will lose them $21,000. Every extra percentage point of response gives them $7,800 extra profit. They need a response rate of 5.8% to break even. They can then use that information in their decision-making processes. We're going to build on the tools we've looked at tonight in the weeks that follow. Next week, we're going to start with linear programming. Linear programming is actually based very much on this what-if analysis we were doing here. Instead of saying, where do we break even? Or what does this input give us? Linear programming says, what value will give us the optimal profit? So how do we maximize our profit? That's what linear programming gives you. And it gives you a lot more rich insights through sensitivity analysis. So that's something to look forward to next week. As far as the computer exam goes, I posted a little bit of information about it online. It's going to cover the material from this week, the next 2 weeks on linear programming, and the week after that on aggregate planning. That sounds like a lot of material, but as we see as we go through the next 3 weeks, it all builds from itself. So you're not going to have 4 separate questions. You'll have 1 question, but it will incorporate elements of everything we're doing here. Closer to the time, there'll be a practice exam for you up on Canvas. Okay, so before we finish up, I want to talk you through what there is online to help you. Okay. So the textbook has excellent information about spreadsheet modeling and linear programming, well worth looking at. My workbook goes through step-by-step guides to those topics as well, showing you how to do it. The setting up Excel videos, they show you how to set up Excel for data analysis. Oops, something's gone wrong there. I'll have to double check if that's working. The setting up Excel videos shows you how to set up Excel for linear programming. The practice questions, they cover spreadsheet modeling, linear programming as well. So have a look at those for some more practice questions, particularly around influence diagrams, data tables, and so on. Next week, we're going to be looking at linear programming. I'm going to flip the learning around a bit for next week. What I'd like you to do before coming to class next week is to start going through this linear programming online learning course. You'll see there's some videos there and some activities to do, and yeah, some review things there. So the theory that you need is all online for next week. What I'd like you to do is go through at the least this topic A there. There's various subsections there, but as you see them, they're all short videos and things to read. So don't worry about the number of items to do. It's just that it looks like it's a lot on the page. It actually won't take you that long to go through that section A. Next week, we're going to go through production mix problems. If you're less strong with Excel, I would suggest having a look through these videos in section B as well, just so you've got a little bit more preparation for when you come to class. So we'll have more time to spend on doing the working class. And then the week after that, we'll do question 4.01, which is part C in class next week. And then the week after, we'll look at network design problems. Yep. So that's there for you as well. There's also extra information up there on the linear programming. I'll post a little video going through some of the things we've covered tonight up on Canvas later this week. I'll also post the lecture recording from tonight up on Canvas as well later in the week. Okay, so that's that. I've gone a little bit over, but I'll end it there. And I'll say, hope you have a good week. I think we all did well in class today, a lot of good interaction and activity. So great, and I look forward to seeing you next week for some more work on this interesting area of linear programming, which, as I said, is a very rich extension to spreadsheet modeling. Okay. So bye for now.
Thank you.
Thanks, buddy.
Thank you.
Thank you.
Thank you.
Thank
Goodbye.
you.
Thank you. See you next week.
Yeah.
Yeah, see you next week.
Hi, Jeffrey.
Bye. Hi. How's it going?
I have a question about the group assignment.
The assignment for this topic is an individual assignment.
No. I want to ask about the group members because last week I remember that you said the group members will be assigned.
Yes, that's for ITLS5050 production operations management. And so, yes, I will assign the group members the next week, because this is the last week to add the unit. So we'll have a good idea of the student numbers next week for ITLS5020.
So when releasing the group member list, how can we get that?
I'll send you an email.
All right.
Yep. But that's for ITLS5020 rather than this unit of study. But yep.
Okay.
Yep. Excellent. Okay.
We're good.
Great.
Bye.
Bye. Take care. Bye for now.